Okay, we're going to look at our binomial series. This is for our A-level further maths. We have seen this last year for A21 regular A-level mathematics. But we're going to look at it slightly differently here today. So we already have an expansion for our binomial series that we got last year. And we're going to look at how we can do this using what we've done with Maclaurins series. So if you have your original f of x, is 1 plus x to the power of n. That's your general binomial series. Then if you differentiate that, you will get f dash is equal to n upon 1 plus x to the power of n minus 1, and your f double dash, and so on, and then your f triple dash. But very importantly, that gives you your f of 0 is 1, your f of dash of 0 is n, f double dash of 0 is n upon m minus 1, and f triple dash of 0 is n upon m minus 1 upon m minus 2. So in general, and this is not my nth term, this is my rth term, I suppose you could say. So whenever your n is equal to r, what you will get is n times m minus 1 times m minus 2 all the way along to n minus r plus 1. And then that's multiplying your 1 plus x to the power of r. So that means your f of r of 0 is just going to be n upon, cut that off there, sorry, it is going to be equal to n upon n minus 1, n minus 2, all the way along to n minus r plus 1. Okay, so for example, that's quite tricky. I don't like that last term, I have to say, but let's look at it in terms of putting in real numbers. So your first term in your binomial expansion of 1 plus x to the power of n is 1, and then nx. So the how I remember this is, the power of this is 1, and I've got one thing. Next one is my x squared term. So it's 2 here, and also it's 2 factorial, and I've got 1, 2 things. Next one is x cubed, and I've got 3 factorial in the bottom line, and I've got n times n minus 1 times n minus 2, so 3 things again. And then my general term is x to the power of r divided by r factorial, and I've got 1, 2, 3 all the way along, and that would be my rth number of things. Okay, so in general as well, a nice way of saying it is this. So how I remember this is if you have 1 plus squiggle to the power of n, it is 1 plus n times the squiggle plus n upon n minus 1 times the squiggle squared divided by 2 factorial plus n times n minus 1 times n minus 2 times the squiggle cubed over 3 factorial. And I would add that into your notes there. That is very useful because quite often, as you'll see in the next example, it's not 1 plus x, it's 1 plus something else. So as long as you know what that something is, you can very easily work out what your expansion is going to be. So we're going to look at our next example, and it says expand 1 minus 3x to the power of minus 2 over 3 up to terms including x cubed. So our first thing, I'm just going to write down that what they want me to expand, 1 minus x to the power of, and it's minus 2 over 3, I should have said. And here, if you think in this one, compared to what we have up above, squiggle is equivalent to minus 3x, and then your n, your power, is equivalent to minus 2/3. So if you understand what I've written up above, you're able to do these questions. So my first term is always going to be 1 plus, and then my n term is minus 2 over 3. My squiggle term is minus 3x, and then plus my n is minus 2 over 3, and then n minus 1. If n is minus 2 over 3, minus 2 over 3, take away 1 and leave it as a top-heavy fraction is minus 5 over 3, and that's going to be minus 3x squared, and that's being divided by 2 factorial. And then my last term, as far as I need to go in this one, is minus 2 over 3 times minus 5 over 3 times minus 8 over 3, and that's times minus 3 cubed, and that's being divided by 3 factorial plus ... Remember, it's an infinite series, goes on forever and ever, but we have to tidy it up. To do the expansion of these, you really are just putting this into your calculator. So when you're putting this into your calculator, well, you've got the 1 obviously, and then you're just putting in, I would just do brackets 2 over 3, close your bracket, and then times minus 3x, minus 3 just to see what you get, and you'll get a 2, and then put the x. And then for your bracket, when you're doing this one out, the next one, I would use my fraction button on my calculator to do this. And in the top fraction, I'd be doing just minus 2 over 3 times minus 5 over 3, and then minus 3 squared. And my bottom line, you can put in your 2 factorial if you don't know that it is 2, and then just press equals. Okay, but you need to make sure the bit that people get wrong is this bit here, because I forget they don't do brackets minus 3 squared. So quite often people put that down as minus 9 when it's clearly going to be minus 3 times minus 3 is positive 9. So just be careful on that one. Very easy mistake to make. But when I did all that, put that into my calculator, I got just 5, and then that's going to be x squared. And then on to the last one. Again, just how we set this out. I would use your wee fraction button, your top line of your fraction. I would just do minus 2 over 3 times a minus 5 over 3 times a minus 8 over 3. And then this bit here is going to be minus 3 cubed. Put that all in, and your bottom line, you're just putting in your 3 factorial. And when I did that again, it came out as 40 over 3. And then remember, you've still got your x cubed term as well. And that is u, and then plus dot, dot, dot. Okay, it doesn't ask for it in this term, in this sequence, but we'll just show it. This is valid for modulus of minus 3x is less than 1, which means your modulus of x is just less than, we'll just say modulus of 3x is less than 1 then, which then implies that your modulus of x is less than 1/3. Okay, because modulus of minus 3x is the same as modulus of 3x, and then bring the 3 across, and it just divides. Okay, where this comes from, if you want to add a wee thing into your thing, just say valid, this sequence up here is valid for your modulus of the squiggle is less than 1. So in this example, our squiggle is a bit highlighted in yellow. It was minus 3x, so modulus of minus 3x is less than 1. So that's where that comes from. Our next example should say expand brackets 1 minus 3x to the power of 1/5 in ascending powers, 2 separate words. It should be of x up to the term x cubed. And then it says take x equals 1 over 32 to find an approximation for 25 to the power of 1/5, giving your answer to correct to 5 decimal places. Right, big mistake people make in mathematics is they read the whole question and they think, how on earth am I going to do this last bit? Okay, when you don't have an idea how you're going to do the last bit until you've done the first bit. So just get started, and let's just do the expansion of this up to the terms in x cubed, and then we will worry about the rest after. So first bit, we're just going to look, and we're going to expand 1 minus 3x it was to the power of 1/5, and see what we're going to get. So here, remember what our expansion 1 plus squiggle is. It was my n. So in this case, it was 1/5. The squiggle is minus 3x, and then plus 1/5. And then that was my n. n minus 1 then would be minus 4 over 5 times minus 3x squared, and that's divided by 2 factorial. And then my last term I have to do here is 1 over 5 times minus 4 over 5 times minus 9 over 5, and then times minus 3x cubed, and that's over 3 factorial. I'm just going to go through that and talk where we got all of those numbers from. So first of all, this is my n, which was 1/5, times my squiggle, which was minus 3 over x. This was my n times my n minus 1 times the squiggle squared divided by 2 factorial. This is n times n minus 1 times n minus 2 times the squiggle cubed divided by 3 factorial. All we do now is go on and tidy this up. I explained in the last video how we would do that. So that's going to be one last example, how we would do that. So that's 1 minus 3 over 5x minus 18 over 25 x squared minus 126 over 125 x cubed, and so on. So you've got some of the marks already for this question by doing the first part. We now have to figure out what we're doing for this next line, which says, take x equals 1 over 32 to find an approximation for 29 to the power of 1/5, giving your answer correct to 5 decimal places. Okay, for the next bit, I'm just going to do as it says. I'm just going to say, let x equal 1 over 32. Therefore, if I do that, I'm going to get 1 minus 3 times 1 over 32 is going to be 3 over 32, and then the power of 1/5. And so that's what my left-hand side is equal to. My right-hand side would be 1 minus, so I'm putting my 1 over 32 into this thing here. So 1 over 32 is going into this big expansion that we just worked out to see what we're going to get. So it's going to be 1 minus 3 over 5 times 1 over 32 minus 18 over 25 times 1 over 32 squared minus 162 over 125 times 1 over 32 cubed. Just do we dot, dot, dot for good measure. And then we're going to look at our left-hand side. I'm going to leave my right-hand side alone for a couple of lines here. I'm not too sure what I'm going to do with it. But my left-hand side, 1 minus 3 over 32 will become 29 over 32 to the power of 1/5. And you can see where we're going to here. Oh, I'm going to run out of space massively here. Apologies, so I was going to run out of space there, so I had to just shrink that down. Just zoom in a wee bit here so we can see it. So we've got left-hand side, we've got 29 over 32 to the power of 1/5. What you can do here is take the 1 out of 32 outside of bracket. So really what I'm doing is 1 over 32 to the power of 1/5 times 29 to the power of 1/5. And 1 over 32 to the power of 1/5 is 1/2. So that just becomes 1/2 times 29 to the power of 1/5 is equal to, and it will be equal to all of that thing that was above. And I'll just write it in this time, 1 minus 3 over 5 times 1 over 32 minus 18 over 25 times 1 over 32 squared minus 162 over 125 times 1 over 32 to the power of 3, and so on. And then the half comes across and it multiplies, so you're going to have 1 over 29 to the power of 1 over 5 is going to be half, comes across and multiplies by 2 then, so it's going to be 2 times 1 minus that whole line again. That's 18 over 25 times 1 over 32 squared minus 162 over 125, 1 over 32 cubed, and so on. And when you do that out, you will get 1.96101, and that was the 5 decimal places. Our last example for this video says, express f of x, which is x over 3 minus 2x upon 2 minus x. Express that in partial fractions, first of all. We're actually going to omit the working out for this. Go back and look at one of the earlier videos or your notes to see the working out in this. So for a, we're just going to say our answer, ANS, is equal to 3 over 3 minus 2x, and then minus 2 over 2 minus x. And we'll just say working omitted. Okay, we have seen that before, how we do that, but we don't want to have space really to do it in this particular example, and we know how to do it. We've done that earlier on in our partial fractions work. Okay, part 2 says expand f of x up to terms including x cubed. So I'm just going to write my f of x this time is, and this first bit here, this 3 over 3 minus 2x, we could write that as 3 upon 3 minus 2x to the power of minus 1. This second bit, and I'm highlighting the minus as well, we could write as minus 2 upon 2 minus x to the minus 1. Now this is very important that we see this, as these are not simple expansions. And why they're not simple expansions? Because they're not in form 1 plus squiggle to the power of n. we need to get it into that form 1 plus squiggle to the power of n. So here, if we look at the first one, what I could do, I've already got the 3 outside, I'll leave that 3. And to get that, the 3 that's in here, this 3 here, to get that to become my 1, I need to pull a 3 outside. So I'm pulling 3, and it's 3 to the power of minus 1 is being pulled outside. Then it leaves me inside 1 minus 2 over 3 to the power of x to the power of minus 1. Same idea for the second bracket. I need to get this 2 to go down to a 1. So I'm going to have to pull out a 2 to the power of minus 1. And then that's going to be 1 minus x over 2 to the power of minus 1. So both of my brackets are now in the form 1 plus squiggle, 1 plus squiggle to the power of n. Okay, sort this out. 3 times 3 to the minus 1, that just becomes 1, so that's actually very nice. Not often it's going to happen just as nicely as that for us, but it has in this case, so no problem. And over here, that's just going to be the 2, and the 2 to the minus 1 will cancel out, so you've just got minus 1 minus x over 2 to the minus 1. Okay, we're going to go on, and we have to do this expansion. We've got 2 expansions to do here then. So I'm going to do square bracket for the first one. We had to go up to, I have forgotten what I've said, up to the x cubed term. So we're going to do, this is going to be 1 plus minus 1 times minus 2 over 3 times your x, and then plus minus 1 times minus 2 times minus 2 over 3x, and that's squared, divided by 2 factorial, and then plus minus 1 times minus 2 times minus 3 times minus 2 over 3x, and that's cubed, over 3 factorial, and then minus, and then you've got to do the same for the second, so this is us on this one over here. So we're going to have 1, and then it's going to be plus minus 1 times minus x over 2, plus minus 1 times minus 2 times minus x over 2, and that's squared, divided by 2 factorial. And then your last term here, I'm just about going to squeeze this in, minus 1 times minus 2 times minus 3. I'll have to move across here, apologies. And this is going to be times minus x over 2 cubed over 3 factorial. And then we've got to tidy this whole mess up. So this whole thing needs to get tidied up. So when we tidy that all up, what you will get is going to be 1 plus 2x over 3. And then that's going to be, the next one is going to be plus, yeah, it is indeed, plus 4x squared, over 9. Then plus 8x cubed over 27. And then over here, you're going to have minus, and I'll put that in the square bracket still. I haven't tidied it up just yet. That's going to be 1 plus x over 2 plus x squared over 4 plus x cubed over 8. And then we'll get rid of that second bracket. That's going to be 1 plus 2x over 3 plus 4x squared over 9 plus 8x cubed over 27 minus 1 minus x over 2 minus x squared over 4 minus x cubed over 8, which works out to be, after a good bit of tidying up, the ones cancel, you're left with x over 6 plus 7x squared over 36 plus 37x cubed over 216. Okay, the last part of the question says state the set of values for which state the set of values x for which the series is valid. I'm just going to do this up here, my part C. Squeeze it into this wee box up here. And I'm going to look at my 2 series that I have. So I've got this series here, I've got to expand, and I had another series here, which I had to expand. So the pink series then, it was valid. So 1 minus 2 over 3 x to the power of minus 1 is valid for modulus of minus 2 over 3 is less than 1. Sorry, modulus 2 over 3 minus 2 over 3x is less than 1, which with a wee bit of working out means that your x, modulus of x, is less than 3 over 2. The other series, which was 1 minus x over 2 to the power of minus 1, was valid for modulus of minus x over 2 is less than 2, which therefore means it's valid for modulus of x is less than, sorry, that should mean less than 1. Therefore, it's going to be valid for modulus of x is less than 2. So we've got two different restrictions. So your answer basically is a more restricted of the two of those. So just say, so the whole series is valid for, and it's just going to be your modulus of x is less than 3 over 2. So you have our single series, our whole series is made up of two separate series. So you have got to take the most restrictive one of the restrictions that have been put in place. And that's it. Okay, that is the end of this video on our binomial expansion at this level.